Stuart. So, hi everyone, welcome to Expert Talks Online. I'm John Dickinson, Chief Commercial Officer at Equal Experts, and this evening we've got the next talk in our continuous delivery series, and this is by Stuart Gunter, who's our security practice lead, and he's going to talk about doing secure or implementing secure continuous delivery. And Stuart will talk about a few ways that you can take advantage of continuous delivery to make security a first-class citizen of software engineering. So Stuart, over to you.
Thanks, John. So I don't know how many of you have joined into some of the previous talks in this series, but there's been a really good background starting right from the beginning with Dave Farley's talk on the rationale for continuous delivery, around why you might want to adopt it and what the benefits are. And then there have been a few other different takes on people's perspectives from different angles, like Lindsay's talking about smoothing the delivery path. So today I wanted to focus on security specifically. And the reason being, this is often an area that I've seen teams struggle with. And it's one that we do try to encourage a lot of good working practices with. I'll share some resources towards the end of the talk that hopefully you can make good use of afterwards or in your own time. And throughout the talk, if you have any questions, I think John may have mentioned already, you can just drop your questions into the Q&A and we'll deal with those afterwards. So to get started, what I wanted to talk about was what appears to be a very common approach to security within organizations. And there's some variation from one company to the next, but the template seems to be fairly consistent. And the template is something along the lines of this. When someone has an idea and they want to take that idea and turn it into something tangible and ship it into production, there's a series of steps that we need to go along that journey to be able to convert that thought into something real that a customer can touch and feel and see and use. And so we've designed security processes to fit that sort of project-centered model of idea to production and complete. Almost very manufacturing-like. Once it's built and it's shipped, it's done and you can largely forget about it. And this sort of process is bookended quite often with two different activities. So on the one hand, right in the beginning of the process, we tend to have some degree of security requirements gathering. More often than not, this is driven through fairly standardized requirement spreadsheets or security checklists that have been built up for that organization over time, and quite often they aren't particularly tailored to the specific idea that is being tested at the moment. So you often tend to spend quite a lot of time going through requirements that either are not applicable or are not quite in line with the thing you're trying to do, which is a bit problematic in the sense that you may miss opportunities to look at really important elements that are slightly niche to what you're building compared to the norm, or you may go over things that are already dealt with in other areas of the business for you, but are part of the requirement spreadsheet. So you kind of have to go through there and say, yes, we've done that. No, we don't have to do that. It's not part of this particular project. Checklists are largely a similar sort of approach to this, but just a different kind of form. So we tend to get that sort of activity going on right at the very beginning, and it often produces a fairly detailed set of requirements or a long list of requirements that the team then has to go away and build. And then at the far end of the process, somewhere as you're approaching getting something into production, there'll be an activity of penetration testing. And more often than not, that is a gatekeeper requirement that a team will have to pass before they're allowed to go to production. And then there's a fairly common approach there again, where there's a requirement to either have another penetration test done when there's been a significant change, or on an annual basis, or some periodic basis. Now, there are a number of problems that we encounter when we come into the world of continuous delivery, because we're not building projects anymore. We're now taking more of a product-centered view of what we're building. And so it'd be good to just talk about some of these shortcomings and why they are problematic in continuous delivery. And then we'll spend most of the time exploring a few different options of what we can do about that. So the first problem is that continuous delivery relies on this feedback loop. Once you've got something into production, you learn from production that feeds back into a new idea or a refinement of an existing idea. And that gets worked on and gets shipped to production. And we're going through the cycle frequently, and we're going through it at pace. And so these activities of defining requirements up front on the basis of a project are not really well designed for very, very small scale increments of delivery into production. They tend to be more heavyweight for that. And penetration testing is just not economically viable. It's not financially viable to pay a third party. It's more often than not a third party company that will come in and do this work for you. You can't really scale that at the kind of pace that you would find once you really get going with continuous delivery, especially if you're doing a large program of work. The next problem is that continuous delivery almost forces the separation of production and live to customers. Whereas in the past, we had this idea that going to production meant going live to customers. Within continuous delivery, quite often the very first thing you ship to production is nothing. It's a basic walking skeleton, as we might refer to it, an application that does almost nothing, but it smooths that path. So you prove that you can get everything you need into production without needing manual intervention. And by doing so, you make every subsequent release to production that much easier. But that blurs the lines on penetration testing now, because depending on the people who are responsible for coordinating penetration testing and setting down those policies or rules within the organization, they may not quite relate to this. And so there's a bit of a translation barrier there that we need to overcome. So we're going to talk about three different things here. First of all is how to look at contextual threat modeling as an alternative to requirement spreadsheets and an upfront large-scale requirements gathering for security. And then we're going to move on to not getting rid of penetration testing, but how do we make it more effective by automating security assurance as much as possible in the pipeline, and then also learning from production. And we'll look at where penetration testing can fit into that model as an alternative moving forward into a more frequent iterative delivery model. So let's dive into the first point here, talking about contextual threat modeling. It's worth clarifying what threat modeling is, in case anyone on the session isn't familiar with it. Don't get too worried about the term threat modeling. It's a well-known term within the security community, but it can be a bit of a stumbling block when people are worried it might be some weird new fancy thing that you need to be a security specialist to do. It absolutely isn't that. It is really, really simple. Adam Shostak has written a book called Threat Modeling, and in the book, in the very first chapter, he says it basically comes down to 4 questions. What are we building? What could go wrong? What should we do about that? And is it correct? Have we done a good job? Validating all that work that we've done. And those aren't necessarily all done in one session, but it's a part and parcel of a complete picture of analyzing what could go wrong with a system. It's worth also considering that we already do this in other areas of software engineering. So if we look at operability, for example, the reason we have things like load balancers is because we've experienced systems going down. And so we know that we need to have availability of more than one instance at a time so that we can share the load amongst multiple instances and make sure that if something does go down, we're not left with 0 availability. Or why we've got auto scaling, because we know that there may be an occasion where we get far more traffic than we're expecting, or that traffic will take a different shape. It's not evenly distributed over time. And so we responded to those by saying, well, what are we building? We're building an e-com site, for example. What could go wrong? In this case, wrong maybe is a good wrong, but we might get more customers than we thought. We might have a marketing campaign that suddenly puts our site under load. What are we going to do about it? Let's do auto scaling, just as an example. So all we're doing is taking the same approach, but applying it to security. So the key thing here is we're looking at how can we do security requirements gathering on a much smaller scale, much more iterative basis. And that really requires a lot more collaboration between security and delivery teams. Each side has a lot of valuable experience to bring to the table. The delivery team knows the context the best. That's why I've said contextual threat modeling. You can't have a threat modeling team in some part of the building that does threat modeling for all the teams and then gives them an output. It doesn't really work that way. But what you can have is people who are more familiar with it, who've been there and done it, facilitating and helping others learn how to do it, taking them through this process, but also helping people not get bogged down in choosing the perfect way to do it. I've had a few conversations in the past where you mentioned threat modeling, and the first question is, what are you using? Are you doing stride? Are you doing pasta? Are you doing this or that? And it can be a bit of a deterrent to people who are unfamiliar with it, thinking they have to learn this formal method for doing it. And I don't believe it to be true. The key thing is, if you follow those 4 questions, it's fairly easy for anyone new to it to come in and answer those questions. So just follow that to start with. If you have a process that you like, go for it, but don't feel bound to following one of those formal processes. But it's a detailed technical discussion. So we want to be able to draw out as much information as possible in a very short space of time, so that we can provide the team with enough information to build the right thing in the right way. And preferably to have them in a form that you know you can test in an automatic fashion as well as you're going through it. So you don't get to the end and you don't have to have a penetration test to prove you've done it. You've already got tests in place to prove that you've done it, and you've done it well, and you've met those requirements. And I've mentioned that varied security experience is valuable. Everyone's got a different perspective on things. If you've spent a lot of time in security operations, for example, you've probably got more visibility in the kinds of attacks that sites are likely to see, and therefore what is a realistic scenario to protect against. Or if you're a pen tester or red teamer, you may have an angle of, how would I break this if I was going to attack this site? The engineers on the delivery team could have those perspectives too, but they'll also bring the experience of, I know what the intricate details of this thing are going to look like. And so they're also extremely well placed to contribute into that, and often are the biggest contributors to those sessions because of that context. But ultimately, we shift security from being a rubber stamping exercise that teams don't really want to engage with, to being subject matter experts that people feel they're getting value from. And I think that's really, really important. If that engagement feels like a bureaucratic process that's forced on a team, then they will find ways to minimize the number of times they have to go through that process, which means you might miss opportunities to pick things up as early as possible. So the frictionless process is really, really important there. And the more you do this, the better you get, the more proficient you get, the faster you get. So to give a real world example here, I was working on a large microservices-based platform some time ago. And one of the teams on this platform wanted to build, or were tasked with building, a file upload and preview service. So the idea was that we'd have this one service that would be responsible for all user-supplied file upload content. They would do whatever steps were necessary to make sure that the file content was safe, and they would then pass it on to other services to deal with processing for whatever business reasons. They would also build some preview functionality. So if I, as a user, for example, had uploaded a file, I could then preview what I'd uploaded to confirm that the file was displaying correctly. I hadn't uploaded the wrong thing or whatever. So we took a threat modeling approach with this team. We spent probably 1 to 2 hours with them. So it was very little amount of time needed, but we focused only on the MVP, which at the time was one file type they needed to support for a particular service. And they didn't need preview functionality right from the get-go. So immediately that narrowed the scope. So if we'd had a long spreadsheet, we would have had to go through a lot more details, probably consider more of the whole project scope that they were looking at. And that may have either taken a lot more time up front or caused them to satisfy a number of security requirements early on that they didn't really need to. Instead, we picked out just a few key things that they could focus on right in the beginning, but also identify what the future areas are to watch for. So I mentioned in the beginning, with penetration testing, one of the criteria for having another test is quite often called when there's a significant change, but that's a bit ambiguous as to what significant means. So one of the benefits of going through this process is we were able to say to this team, look, if you start supporting other file types, that's significant, that every file type is going to have a different way in which it can be abused. If you're talking about macros in Office documents, it's very different to talking about zip files or image files. So the moment you want to support a new file format, come chat to us first. We'll just have a quick session to go through it, and we'll point out some of the areas where you may need to think about that. Or if the process changes, like if you're handing it off to a service that's doing something different with it. Let's say one service is just parsing file contents like a CSV file and processing it, but the other one is uploading files that are then going to be opened by an end user on the corporate network. Those are completely different scenarios. We need to look at those in different ways. So removing the ambiguity was really helpful, but it allowed us to spend 1 to 2 hours with the team and get them up and running really, really fast, but still meet all the requirements that they needed and provide enough detail that all of that could be testable as they were building it. So threat modeling is a really, really good thing to do, and a really, really simple thing to do once you've gone through a few iterations. The next thing we want to move on to is automated security assurance. So we talked a bit about penetration testing and how that's used as the primary security assurance mechanism for a lot of companies at the moment. And how do we shift towards this place where we're not so reliant on those, not that we don't use them, but we use them more judiciously and for a particular purpose rather than as a catch-all for all security vulnerabilities. And I want to highlight right from the start, there's a lot of security tools out there, but there's also a lot that you'd need to do a security test yourself. So tools will not cover everything that you want to cover. A really good example of things that fit into either of those camps is if you wanted to validate your TLS service certificates, Cypher suites or TLS levels, there are great tools that will do that for you. You don't need to write that stuff. That's fairly generic and it's fairly consistent from one system to another. Unless you're building a TLS processing engine, you probably don't need to build your own tools to test it. However, if you're building an application, let's say you're building a social media site and there's content that people are allowed to see and there's content they're not allowed to see based on authorization and privacy settings, that's very unique to your application. There are probably not going to be security tests out there that will do that. So we're looking at how we can accompany security tests and security tools together to try and provide comprehensive coverage over everything we're building as we're building it, using threat modeling output to drive those security tests. So in the context of the image or the file upload service, if we said there are particular things that we want to do with certain kinds of files, so certain types of files, yeah, so if you're processing something like a zip file and you're concerned about zip bombs, right, so if we had particular file types in this particular scenario that we wanted to validate, we could easily write automated tests for those sorts of scenarios. So for example, a zip bomb, if we're handling zip file uploads, we could test for that. We could have an automated test to prove that we're not vulnerable to that particular kind of scenario, and so on, rather than relying on a pen tester coming at the end and providing on those sorts of answers to us. So the next thing we need to look at is how do we not just cover applications, but infrastructure. So it's really important that we consider things like policy as code, for example. If you've come across that, it's a really powerful tool to use. There are tools like Open Policy Agent, which is fairly generic, but then you also get fairly specific platform provided tools like Google's GCP provides a tool called Forseti, which does a very similar sort of exercise using things like Rego templates, where you can specify a policy that's testable automatically, and you can continually validate your infrastructure against that. And in some cases, you can also validate things like Terraform plans against those policies before you apply them. So it's a form of testing prior to rollout, prior to deployment, where you can make sure that if you have a security policy that you don't want to violate, say the canonical example of public S3 buckets, you can implement that as a policy. You can validate that nothing is going to get deployed to production or any other environment for that matter if it violates that policy without you knowing about it first. And if there's a valid reason, then obviously you can provide exceptions for those sorts of things, but it's a conscious choice rather than an accident that slips into production too late. So if we've got security controls that are critical enough that we shouldn't go live without them, the key thing here is that those should be built into automated tests. Coming back to one of the points Dave Farley mentioned right in the beginning of the series was everything should be part of that process, that pipeline to get to production. And if it's painful, we need to optimize it and automate it and get it into that process so that we can go through it really, really smoothly every time. And if we can automate security testing, then that just saves one more hurdle that we have to jump at the end. It saves one more lag at the very end of the process. So a great example of something that I've worked with along these sorts of lines is coming to pen tests. I was working with an organization where they had a 6-week lead time for pen testing. So that's from the moment you decide you need a pen test and you define it, you scope it, you get the quote, you get the purchase order, sign off, wait for the availability, have the test done, and then get the report. Now, if you're dealing with a team that's delivering to production multiple times a day, that obviously isn't going to work if they need to deploy frequently and have security testing in place. So instead, what we looked at is, well, how frequently are teams deploying? When was their last pen test? We were able to draw out some statistics over a period of about 2 to 3 years. It's a fairly mature platform. And we're able to demonstrate the business case for saying, let's invest rather in having automated testing in place earlier on. So we could still do penetration testing, but rather than doing penetration testing on a very small scale, like per microservice, or in some cases for a single API that was being shipped out, let's rather rely on automated tools to catch as much as possible, and then use penetration testing later as a validation of those tools working effectively. Once we're in a position where we've automated all those security tests, or at least as much as possible, we're then in a much better position when we get to production to learn from production. More often than not, this is the point where a lot of teams are saying, right, how do we build security monitoring? Now we're live. How do we demonstrate compliance, depending on the environment you work in? Maybe you're spending every sort of quarter or every 6 months, spending a lot of time gathering information to prove that the system is still compliant with requirements. And if we've invested that time up front in automation, that is our compliance checklist every time we ship, or that is our penetration testing equivalent during delivery. And instead, what we can do is say, what are the things that we want to learn from production as we go? And as we start to see real world usage on that system, on that platform, on that service. And it may be things like temporal changes, like we want to scan for certificate expiry. And so we can learn from that sort of thing. How do we optimize that? How do we improve that process and avoid that being detected in production and instead fixed earlier on? How do we react when there's a newly discovered vulnerability? And is there a way we can smooth that process so that when someone reports something, we're not scrambling around trying to figure out who to talk to? We've got a process that's well oiled and we know exactly what we're doing, and we're communicating effectively with the outside world as well. So there are all sorts of elements that we can use here to learn from production if we're prepared, and if we're not distracted by other toil that we'd otherwise be doing if we don't have the automation tooling behind us. So a few examples that I wanted to draw out here is we've got to deliberately design this feedback loop. We talk about the feedback loop from production to the idea, but it's not an accident. It's not something that just happens because we're doing things iteratively. We're intentionally having to learn from production. We should be doing things, not necessarily in the security world, but things like A/B tests are an intentional attempt to try and figure out which of two or which of multiple options is better, are going to yield a better business outcome. And we should be doing similar things with security to say, well, how do we optimize what we've built and improve on it over time? And so to me, this is a really good place where penetration testing comes in, alongside other techniques like vulnerability disclosure policies. So we actively solicit feedback from the security community through bug bounties as well, whether your disclosure policy is part of a bug bounty or just a way for people to safely report issues if they find them, and efficiently report issues as well, but also using things like chaos engineering. So a couple of talks back, Lindsay was doing a great presentation on continuous delivery, but he's also done a lot of work on chaos engineering and helped a number of our clients in that area. And it's a really, really valuable exercise to learn how your system behaves under unexpected behavior. And there's a lot of complement there with security and red teaming as well, where you can actively try to do things and use that as a means to prove whether your automated security tests have identified all the issues that you should have identified early on, or you wanted to identify early on, or that your security monitoring is effective and you can actually detect when things are going wrong in production, rather than assuming you can and not really proving it to the team. So there are a number of different techniques we can use there to benefit that feedback loop and improve the product over time. But we've got to be deliberate about it. We've got to have the time to invest in these activities as well. So picking another example here, one of the companies I was working with had a very large household name company. They had a large website that was very heavily used, very large retail company. They also hadn't yet published an official vulnerability disclosure policy. And the issue arose one day where someone outside the company, maybe it was a customer, maybe it was just a security researcher that discovered something, they found a vulnerability and they really struggled to report this to the organization and for it to get to the right team. the end result was that we had a public blog post and tweets about the security issue that were less positive than they could have been if we had actively provided a good mechanism for that person to report the vulnerability in. We also learned that it took us about 2 weeks from receiving the vulnerability to contacting the correct team that was actually responsible for that service that could do any work to fix the vulnerability. So that was 2 weeks of dead time inside the organization that we weren't prepared for. So what we did is we had a post-mortem about that. We analyzed all the timeline of the incident and how it was reported and what we could do better along the way. And we ended up having a bit of a collaborative exercise between the engineering teams and the security teams. We created a security TXT file for the website that would help security researchers learn where they could report issues. And that also directed them to a vulnerability disclosure policy that we put onto one of the bug bounty platforms. They could then see that they could do so safely. They weren't concerned about any kind of heavy-handed legal response from the company. They knew that we're open and receptive to those kind of reports. And so we worked together, we got this live, we got approval from legal to put the policy live. And within about a week or two, we had our first report come through. Also still unsolicited, just someone who discovered an issue. And the change was radical. Instead of originally what we had, someone struggling to contact us and taking 2 weeks to find the team, we received an email, and within an hour of receiving the email, we had the team working on fixing the problem. And that is a massive testament to what you can do when you're able to learn from production, when you specifically gear up your processes so that you're open to getting those sorts of learning experiences, whether it's a bug bounty program or even using your existing penetration testing company or pen testers if they're in-house to actively exploit production or probe production for vulnerabilities. Those are really valuable ways of making sure that you've got the coverage that you expect when you're doing security testing. Because ultimately what we want to do is look at those things and say, well, why did we not detect that earlier? If we've got all this automation in place, are we getting good value for money? Have we bought the right tools? Have we written the right tests? So it's a good sanity check that we're actually investing money wisely in those early automation processes and not just doing it for the sake of automating it. So it's a really valuable exercise to do to round that loop off. In summary, I wanted to just mention continuous delivery is a journey. It's not something that you flick a switch and suddenly you're doing all these radically different things. Dave also mentioned this in the very beginning of his talk, I think, having different clients of his where some were at the stage where they were doing a deployment once every 3 months, and others were at a place where they were doing it maybe once every few hours or every few days. There's a very wide spectrum there. There's a lot that needs to change culturally and process-wise and technologically within an organization to do continuous delivery. The key thing is to pick out manageable small chunks that you can implement one step at a time. So take the iterative approach to implementing all of these sorts of ideas as well as you go. Don't be put off by what may seem like a really high mountain to climb. If you pick the thing that's most painful and work through it and then iterate, what's the next most painful thing, and iterate, it only gets better from there. You may have noticed on each of the slides as I was going through this that there was a link at the bottom of the slide to the Secure Delivery Playbook. This is an open source project that we've been working on with our security practice, and there's a lot of varied experience within the practice and other people who worked with other organizations, whether it's government, finance, retail, manufacturing, whatever. And we drew together a lot of experience from a wide group of people and codified that into the Security Delivery Playbook. It's all open source, it's on GitHub, it's got a Gitbook site as well. If you want to check that out, we'd really encourage that. If you want to contribute as well, please do so. There is guidance on how to do that if you're interested. But it's basically a set of principles and practices that we think are very effective within continuous delivery. So if none of these three things resonates, maybe you've already solved some of these problems and you're looking for other things that you may want to focus on, the Secure Delivery Playbook is a really great place to explore some of those ideas. Thank you very much. I'll wrap it up there. And John, do you want to take over for Q&A?
Awesome, that's brilliant. Thank you, Stuart. Yes. So first of all, I see some questions coming in the Q&A tab. That's brilliant. So now is the chance for people to drop their questions in. I say now, but you can add more questions as you go based on what we're on what the panel is saying. And apologies for my dog barking in the background. Just to explain the fishbowl process a little more, what we will do is if anyone from the audience wants to join and answer any of the questions that come up, then all you have to do is you raise your hand, and Steve, who is in the background, will bring you in as a panelist and knock out one of the other panelists. Anybody from the audience, if you do want to join, and then you want to speak, so you must start off muted, and then if you unmute, that's your signal to say, "Oh, I'd like to speak next," because all the panelists can then see. Okay, so let me see. The other thing I need to change, just if you give me a second, is that you can see all the panelists, because I think at the minute you can only see myself. I'm going to move over to gallery view. So hopefully, could everyone just give me a little, send me a message in the chat to say, can you see the rest of the panelists? You should be able to see myself. You should be able to see Tommy Hamilton. Tommy, give us a wave. You should be able to see Daniel Gartman. Hello, Daniel. You should be able to see Stuart, of course. And Adam Hansrod. Can everybody see Adam? Yes, we can. Thanks. Brilliant. Thanks, Adam. All right. So again, just remind you, we can you can vote on the questions. So vote them up, and I'll pick the one at the top. And I have a reminder, thank you, Steve, that says, everybody who's talking, please be careful not to disclose confidential information or rude comments about any organizations, or disparaging rather, not rude, because the video this is being recorded and we do want to publish it on YouTube afterwards. And I think Jason, you have asked a question in the chat. If you could just pop that into the Q&A, we'll pick it up when it gets voted on. Right, I have stalled long enough. The first question is from Ralph Aga, and it is, thank you for the Playbook link. Have you got any other good reading on secure software delivery lifecycle? Thank you.
I can start by answering that. Yes, the Playbook actually does have links to a bunch of other resources in there. So I'd have a look at that. Some of the key resources that we do reference in there are things like BSIM, which is the Building Security and Maturity Model. There's a bunch of OWASP resources as well that are well worth looking at, like the SAM, which is the Security Assurance Maturity Model as well. So those are really good starting points for a secure SDLC if you want to have a look at those. The Playbook is a bit of an overarching document, so it'll direct you towards things like that, but then also some other areas of focus, like more lower level technical details that you may want to implement in securing Docker images, for example, or whatever it might be. So it's a fairly broad range, but I'd recommend having a look at OWASP SAM or BSIM as a starting point.
Great. Okay, cool. We will put that as done. Thanks for the note, Ralph. That's awesome. So our next question is from Ollie, and he said, Ollie Newsham says, can you explain a bit more about security.txt? Is it a widely known thing?
I can take that one, John. Yes, it is within the community anyway. And I'm sure whoever asked that question probably jumped on Google. And you can go to a place called securitytxt.org and explain everything about it, where to plonk it, the well-known endpoint that you can point it to. But be wary though, because similar to Stuart's story about an organization that gets stuff in, what you do get is people that then see this and see that as I know I can get something out of this organization. So being prepared for that is really important. You'll get people asking for Amazon vouchers for their hard work, or just pure old cash. It very much depends on the individuals and what they've done. And you can go from not having anything come through the door to having loads of stuff where the only way to describe it is chancers who will just find anything at all, even a spelling mistake on a website. But going back to what Stuart said before, if you're prepared and you've got an operational process to handle that input, it can be invaluable, and you're effectively getting testing for free. But it's also just good hygiene in the sense that if someone needs to contact someone, it's a good way to get the email address. If people are nervous, they can encrypt stuff, and you can throw in your PGP key and just give general details about stuff that will help someone get you from A to B in the most efficient manner. So in short, is it a well-known thing? I don't think it's generally well-known outside security circles, but within it, definitely.
All right, brilliant. And I don't see anyone else. Oh, Daniel?
For the next question, I can take it.
Okay, great. So I just want to make sure you're not surprised. I'll say done. So thanks for that question, Ollie. This is the question from Alex about with 3 votes now. So how would you introduce chaos engineering with existing systems that hadn't started with this from the start? Is it difficult to start applying?
So we had recently a similar situation with a client, and I mean, what's key is like we started doing that like in non-production. That's what I would say like as a advice. Don't try doing that in production because of the consequence. Even though like things such as like monkey cows injury and so on, but I mean, start with non-production, and if I mean, that's what I would kind of give as an advice. And it's not hard, basically. It's just, I mean, like for us, what we started, for instance, doing is we had like, everyone in the team was like, after the other was kind of destroying something. And then the other team had to understand with the monitoring and so on, what was going on. And basically then sometimes we saw we had some gap in monitoring and so on, and then we improved it. And yeah, that's how we kind of started doing it. We do that now every couple of months for 1 or 2 days. Yeah.
I think I can kind of add some kind of advice as well. I think if you've got an existing system or a set of kind of services that don't have really kind of any of this kind of thought going into it from the start, you can always start with, you know, picking your experiments. So, you know, come up with a big list of here's what we could go and do with all our various systems and services, and just picking one and focusing on one small little thing, gaining a bit of confidence in kind of, let's say, for example, your email sender and what could go wrong with that, and then growing outwards and seeing what else you can do and checking in on other services, how else it could fail and how else it could, you know, we could further secure or harden that.
Brilliant, awesome. So don't start with your live production database. Cool. All right, thanks for the feedback, Alex. That's brilliant. He says great advice. Cheers. So well done, both. So the next question is from Jason Einan. So the talk focused a lot on practices to support securing an application. Have any of the panelists had experience in hardening a CI/CD pipeline? Best practices, for example, Docker Docker running. Docker running as rootless is something that I have implemented. Are there any other recommendations?
So I don't want to completely take over on this one, John. I'm sure the other guys will jump in as well. But it's such a good question in the sense that I don't know about anyone else, but build agent stuff that sits in pipelines has almost got some magical power, and then people forget that it's just another thing. And quite often there's a whole load of stuff that it can do. It's got access to things that nothing else has got access to. It's highly privileged. It's often on every IP whitelist. It's something that if you can target that, then, you know, the world is your oyster. And it shouldn't really be seen as anything different. You should harden it in the same way as any other box on your environment. Absolutely. It does get difficult, and I guess that's what the question is. I think just going back to basics and seeing that as another thing to threat model. So all the stuff that Stuart said before, go through like who has access, where is it visible, when will it be used, how often, how does it scale, if it does scale, how does its IP address ranges change, all that sort of good stuff that you would do anyway. Just apply it to those services because they just get neglected. They're seen as, well, this is important to get stuff out, so I don't care how it works, just make that damn thing work. And it's easy to leave something like that exposed. So yeah, that's all I have to say on that. It's a tough one to answer.
Maybe as well, another aspect is very often like pipeline, they need access to different systems to deploy or to access like repositories to push image and so on. And I think something important as well is try to avoid using static credential and to use something which is dynamic credential and basically they're just short-lived. That's another thing I would say.
Yeah, picking up on that, that's something I've worked on fairly recently, where we have a CI/CD pipeline where obviously to be able to deploy automatically, you need credentials to be able to deploy all the way through to production. And so we did some work to make sure that not only are the service accounts least privileged, but also we do daily key rotation, and we inject those service account keys into the relevant pipelines based on where we know they should have access to deploy. And we rotate those keys on 24 hours basis, so that if the threat model scenario behind that was if someone leaked a key in a log, a pipeline log, for example, it's no good the next day or thereafter. If a team member leaves, then the next day they come in, the key that they could have copied out of the pipeline config the day before is no longer any use. So, but it comes back to, like Tommy said, threat modeling. If you don't have a scenario to threat model, you could very well do good work, but not be able to explain why, or do work that just keeps you busy, but doesn't necessarily solve a major problem. So I would always start with a threat model first.
Great. Excellent. So that is, thanks for the question, Jason. And the next one we have is from Rajesh Nair, and generally we get NFRs in which security requirements are not explicitly mentioned. In such scenarios, what should be the strategy?
This is a surprisingly uncommon, common scenario. I'm getting my words muddled up. It's not uncommon for a team to not be given explicit security requirements, and I think that's the best thing you can do in that situation, or at least in my experience, what I've done in that situation, is to take responsibility for the service. We're very much believers in you build it, you run it, and taking a very paraphrased quote from Werner Vogels, the CTO of Amazon, his comment was along the lines of, we move far too fast to rely on external security checks. Everyone must be a security engineer now. And to me, that's not just about building security or implementing security requirements, it's identifying them as well. And so that's why in the beginning, talking about threat modeling, I was keen to stress that this isn't something you can give a security team to do behind closed doors and they come and share the threat model with you. Just like architecture doesn't work when people do it in a room somewhere separately and bring it to a development team, threat modeling doesn't work that way either. So do what you can as an engineering team. You'll be surprised, if you haven't tried it, you'll be surprised how much you can unearth or identify that worries you as an engineer, thinking what could go wrong within the system that you're building, and take that as your starter for 10 to whoever it is that's supposed to give you those requirements or sign off on them, and just say, this is our view of what we think the security requirements should be. Do you agree? Have we missed anything? It kind of forces that decision to be made rather than waiting for someone to give that to you. But it can be tricky.
Okay, great. Thanks, Rajesh. Thank you, Stuart. So the next question is from Sandra Kota. How do you introduce continuous secure delivery to a relatively new team that has just done a new product without a lot of functionality yet?
I was just going to jump in and say that forgetting the actual what the product is or what you're trying to achieve, one thing for me is to try and dispel any magic. There's so much brochureware out there and so many products that promise the world. And in the stuff that Stuart went through, we could list off a whole lot of things that you can incorporate into pipelines, automated testing. There's so many tools. And the reality is, once you get down to the nuts and bolts and you start getting output from those, all the work is still ahead of you. It's really, really difficult. And you need a combination of people who understand how things work, like developers and architects and everyone else, and the security focused people to work together. And actually the ones that are the best at security are the likes of developers and so on. They just don't know at that point. And it's quite a frightening position to be in as a security person, because you know in your heart that given enough time, and once you give them the right pointers in the right direction, they'll be way better than you and do you out of a job. So, but it's totally true that once they get into that mindset and understand that the products are not made out of magic, you have to go through things systematically and try and understand them. It's really, really difficult and painful. But if you can get to a position where everyone appreciates the limitations, all of the false positives, the hard work that has to be put in, you can actually get quite a lot out of it. And if you can get to that position, regardless of what the thing is, then you'll definitely achieve some really good stuff. That's what I'd say.
Yeah, I think that's a really good point. I'd add to that, one of the mistakes I see a lot of teams making, it's a very well-intentioned mistake, but it does lead to a lot of problems, is diving headfirst into using a tool that they're not really familiar with yet, particularly automating something that they can't do manually. And to me, the biggest mistake is automating something you can't do manually. If you can't do it once by yourself, then you need to maybe invest more time understanding it better before you automate. All automation does is the same thing faster and repeatedly. That's all it does. So the best example I've got of this, which I think I've seen literally everywhere I've worked, is a WASP Zap. It's seen as a bit of a magic tool, to use Tommy's words, that will solve all your problems. And it's a fantastic tool, but it emerged as an aid to a pen tester first. And so a lot of the functionality and the understanding of how it works, you'll probably gain better by using it through the user interface, setting it up as a proxy and just experimenting with it. But unfortunately, because a lot of people don't necessarily have as much time to spend on those sorts of activities, they'll look at the Zap docs and they'll say, oh, I'll just do the baseline scan, and they'll turn it on and they'll fire it at their app, and it'll not return any results, and so they'll say, great, we're clear. But they don't necessarily look at the configuration of it. They don't necessarily look at which rules they turned on or off, which ones are even relevant. Maybe they're scanning for SQL injection, but they don't use a SQL database. So it's really important to understand the tools and the objective you're trying to achieve when using them. And that if that isn't done, then I think you'd get to a point very quickly where you get quite frustrated with trying to implement secure continuous delivery, because you'll think, oh, this is a waste of time. It doesn't actually work. But actually, it's just needing to invest some of that time up front, learning the tools, learning the principles behind those tools and how a vulnerability actually works before trying to fix it.
Cool. All right, brilliant. Thank you. And thanks for the question, Sandra. And our last question this evening is from Josie. And the question is, how about integrating information related to compliance testing? Integrating process data. So I think this is about levels of security compliance and putting that into the secure delivery process.
I think I can potentially answer what I think this question is asking. I think, if you've got any sort of requirements, then you can most likely build some tests around it in some sort of tool. And Stuart mentioned that kind of, was it policy by code? Those sorts of kind of tools and practices are going to help you build up those kind of battery of tests that you can then go and put into your kind of continuous delivery or build and deploy pipelines, and using them, you then have that kind of continuous compliance checking going through anything through that pipeline. I hope that answers what I think you were asking.
Well, one thing that stands out when I see compliance testing is if you look at like the cloud space at the moment, they love that stuff. They just can't get enough of it. And if you look at something like Azure with Security Center, it will tell you how compliant you are from a GDPR point of view, PCI, SOC, SOC 2, whatever. It'll just throw stuff at you, endless things to go and review. And it comes back to that point before that Stuart was making, in that you need to understand what it actually means in real terms. And you get all the fancy graphs and you get the numbers, But unless you can sit down and invest the time to actually say, well, do we care about that? Like, it's in a dev environment, and we've done things on purpose to make it that way. So let's negate those. And then ones where the ultra high risk and they're flashing red, again, is the context that it's in actually a serious concern? And likewise, what inevitably happens is that you end up with genuinely good stuff in there that just builds up over time. People start to ignore them. They leave them for months and months. And then when they actually come to review them, the numbers are so great that they're just exhausted and they can't be bothered anymore to even try and attempt to consume that amount of information. So up front, get an understanding of the baseline of what is good for you, understand the things that you really, really care about, and try and digest them in that context. Because if you can't, you just end up with a very pretty report that no one will ever look at again.
Yes, yeah, sorry, just to kind of add on to Tommy's point, that he's completely right. It's don't go and just write up all of the compliances tests, work out what's relevant for you.
Yeah, the one thing I would also contribute to that is bring the people responsible for signing off compliance along on the journey with you. Don't invest months and months building all this stuff and automating it and then take it to them and say, hey, look what I've done. They need to be brought on that journey with you. And if, as much as secure continuous delivery is new for engineering teams, policy as code and compliance as code is extremely new. If you're dealing with, say, a QSA for PCI, or if it's an internal audit team or department that have to come around every year and check the compliance of different parts of the organization, engage with them early, explain what it is that you're trying to do and how it works, because it's probably quite a foreign concept to them. It's probably a very, very new thing. Make sure that they're bought into the idea early on, and that will make it so much easier when you come to actually getting that compliance sign-off. You're not then doing double the work of automating it and still having to do all the stuff you used to do anyway.
Okay, brilliant. Well, that actually brings us to the end of our questions and the end of our session this evening. So we do make a point of finishing as close to 7 as possible, just because, well, 7 BST for anyone in the UK, just because everyone's spending so much time in front of screens at the moment. So I'm going to close it down there, and I'd like to say a big thank you to our panelists this evening. So Adam Hansrod, Tommy Hamilton, and Daniel Gartman. Thank you so much for joining us and those great answers. Big thank you to our speaker, Stuart Gunter. And I'd also like to say thank you to everyone who asked questions. So thank you, Ralph, Alex, Ollie, Jason, Rajesh, Sandra, and Jothi. That was brilliant. I mean, the questions that you all put forward is excellent and really sparks the conversation. So thank you so much for that. Next week we will be back with I believe this is the last in our planned series of talks on continuous delivery for now, which is with Lisa Crispin. Yes, Lisa Crispin. Apologies. I had to take I had the name. I had to take a double take. So yes, Lisa Crispin is joining us from the US, and she'll be talking about a whole team approach to quality and continuous delivery. So that will be fantastic. And I think we're trying to organise a full panel session after that for the following week, where a number of speakers will come back. So I want to say thank you once again, everybody, for joining. Everybody stay safe, stay sane, and have a super evening.